How do slope dynamics cause landslides? Have you ever wondered what makes a hillside suddenly give way, sending rocks and soil tumbling down? This phenomenon is known as a landslide, and it happens when the forces pushing materials down a slope become stronger than the forces holding them in place. Let's break down how slope dynamics play a key role in this process. At the heart of slope stability is a balance between two types of forces. The first are the driving forces, which push soil, rock, and debris downward. Gravity is the main player here, acting on the weight of the slope materials. Other factors, like added loads from buildings or water saturation, can increase this downward push. On the other side, we have resisting forces. These are what keep the slope materials secure. They include the internal strength of the soil and rock, friction between particles, and even the roots of plants that help bind the soil together. The angle of the slope also matters. Steeper slopes have more driving forces working against them. When the driving forces increase or the resisting forces decrease, the slope can become unstable. Several dynamics contribute to this imbalance. First, consider the slope angle and geometry. Steeper slopes experience greater driving forces due to gravity acting more directly downward. Each material has a natural angle of repose, which is the steepest angle it can maintain without sliding. If a slope exceeds this angle, it becomes much less stable. Next, the type of geological material on the slope is important. Different rocks and soils have varying strengths. For instance, sedimentary rocks with layers that dip toward the slope surface are more susceptible to sliding. Over time, fractures and weathering can weaken these materials, reducing their ability to resist movement. Water saturation is another critical factor. When soil and rock become saturated with water, it reduces the friction and cohesion between particles. Heavy rainfall or rapid snowmelt can increase pore water pressure, making slopes more likely to fail. Vegetation plays a protective role as well. The roots of plants help to hold soil together, increasing stability. When vegetation is removed due to deforestation or wildfires, the slope loses this natural support, increasing the risk of landslides. External triggers can also set off landslides. Events like earthquakes or volcanic eruptions can suddenly increase driving forces or decrease resisting forces. Human activities, such as excavation or urban development, can destabilize slopes too. All these factors interact to determine the safety factor of a slope, which is the ratio of resisting forces to driving forces. A safety factor greater than 1 indicates stability, while less than 1 suggests a high likelihood of failure. In essence, slope dynamics cause landslides by altering the balance between the forces at play. Changes in slope angle, geological conditions, water content, vegetation, and external triggers all influence this balance. When the driving forces overpower the resisting forces, a landslide occurs, leading to potential damage and danger. Understanding these dynamics is vital for assessing landslide risks and taking steps to minimize their impact.